Hey everyone, just want to go over a quick video summarizing trig stuff. So the first thing to know is that pi radians, which we typically don't actually write out the units of rad, but pi radians is 180 degrees. Okay, so now we can use this, for example, if we have to do 5 pi over 6 radians and we want to convert to degrees. Well, how do we turn pi into 5 pi over 6? Well, we had to multiply by 5 over 6. So we should do that here. We should multiply it by 5 over 6. 180 divided by 6 is 30. So this is 150. So the answer here would be 150 degrees is what this is. So, all right. That's just unit conversion. And that's all really got to say about that. Let's go ahead and kill this thing. Boom. Let's look at this one. All right. Let's make it a little bit bigger. Sweet. So this is kind of just knowledge of not even the unit circle, but just some popular degrees. This should pop into a circle. Nice. Sweet. So hopefully you're comfortable with me saying that's 90 degrees, which means that if we're going from 0 up to 90, and 90 degrees is the same thing as 1/2 of 180, so that's pi over 2. And here's 180 degrees, which is pi. And so if this is 1/2 of a pi, and this is 2/2 of a pi, this is 3/2 of a pi. So 3/2 pi, that's the same as 270 degrees. Okay, so sine, the whole idea with the unit circle and sine and cosine, all that stuff, is if you have some angle theta, then it kind of makes sense if you live on a unit circle. So unit circle is a circle that has a radius 1. So for example, these spots here, they're distance 1 away from the origin. So we can list off those coordinates, 0, -1. Great. So hopefully it seems reasonable that if you know the angle theta, then you should be able to figure out the x and y coordinate, which means x is a function of theta and y is a function of theta. Sort of as theta increases, x changes and y changes, and it sort of comes all the way back around, and okay, fine. So these are such special functions, they were given names. And so this function is called cosine theta, and this function is called sine theta. Okay, so when we look here, this is saying when theta is 179 degrees, so you should imagine something that's like basically 180, then what is the y value when theta is 179 degrees? And well, it's positive, right? It sort of lives up here. It's something small, but it's positive, right? Okay, let's play the same game. So now theta is 62 degrees, and 60 is less than 90, so that's probably somewhere around here. Maybe this is 62 degrees. And then cosine is the x-coordinate, so it's asking how would you describe the x-coordinate for this dot? Well, it's positive. All right, it's positive. And you just kind of keep doing this over and over. Okay, now I have 2 pi over 19. 2 pi over 19. So 2 pi is doing a full rotation, 360. So, whoa, that's 2 pi, okay? If I only travel 1/19 of the way around, well, that's definitely less than 1/4. 1/19 is going to be something like this, right? So sine, we're looking at the y value, it's going to be positive. So positive. Okay. Positive. Great. All right, so here we are. We have 16 over 21 pi. Gross, but fine. Well, 16 over 21, that's bigger than 1/2 pi, but it's also less than pi, right? This number here, 16 over 21, it's bigger than 1/2 because 1/2 would be 10.5 over 21 would be 1/2. So this number here is definitely bigger than 1/2, which means, so 1/2 pi would get us to there. So we go beyond that. We're going beyond 90 degrees. But do we get to 180? No, because This number here, it's less than 1, so it's less than a 1 in front of a pi, so it's somewhere in this quadrant. All right, how would you describe the cosine in that quadrant? Well, that means how would you describe the x value? Well, it's negative. Okay, so that's all that takes for that. We're just getting used to the cosine is the x coordinate, the sine is the y coordinate. And then you just have to be do some logic on some fractions, but you can do this. All right, so that's that problem. Let's take a peek at this thing. I'm basically going to run through all the trig just because, we're really not going to focus much on trig for a little bit. And so I didn't want to hit it too hard, and I'd rather we focus more on it when it comes up. So, all right, find the exact value. So not a decimal, okay? And we're not going to use a calculator. So how are we supposed to do this? All right, there's two famous triangles. All right, so they are the 30, 60, 90 and the 45, 45, 90. All right, so in this little mnemonic, this is all in degrees, but if I were to say it in radians, it's the pi over 6, pi over 3, pi over 2 triangle, and the pi over 4, pi over 4, pi over 2 triangle, right? So sort of 45 is pi over 4, 90 is pi over 2, and then so on and so on. Okay, so these are famous triangles. Let's talk about them. So I'm just going to draw something like this. And clearly that's supposed to be my 90. So now this right here is my 30. It's my small angle. Okay, blue will be my bigger angle. So there's my kind of, let's do this. Let's zoom in. We got pi over 3. We got pi over 6. Boom. Okay, so the ratios for this triangle are 1, 2, and root 3. So these are ratios. So really I could have said 1x, 2x, and root 3x. Okay? So, this thing, 4/3 pi, if I were to draw a unit circle, boop. All right, so we want to deal with 4/3 pi. 4/3 pi, well, this is pi plus an extra third of a pi. All right, so if we handle this pi, that means we rotate all the way to here. There's pi. And then a third of a pi means we get a third of the way back over here. So maybe that's like this far. Okay. And probably be more like, more like this. There we go. Great. So we'll call this pi over 3. All right. So the reason I wrote it kind of silly like this is because I want to make one of these popular angles stand out. And the pi over 3 is what's going to stand out. And so I really want to, I should color coordinates. There's my blue. So let's make pi over 3 stand out. Here it is, pi over 3. Okay. Now, let me clean this up. 3. Great. So this dot here, we care about, what do we care about? Sine. So that's the y value. We care about the y value of this dot. It's got x and y. We care about the y value. All right, so we can see that it's negative. This is a unit circle, which means it has radius 1. So for example, this spot here is 1, 0. This spot here is 0, minus 1. Okay. And it also means this hypotenuse here is length 1. All right, so now we go to our reference triangle. Our hypotenuse has length 1. So then we can solve for x. X is 1/2, which means the leg that touches our angle, so it's adjacent to our angle, that's going to have length 1/2. So if we go back to our triangle, here's our angle. The leg that touches it right here, this is 1/2. Okay, and then the other leg, which I guess I'll just kind of emphasize in blue, this leg right here, it's the one opposite our angle. Its length is going to be √3 times 1/2. So this length here is √3 times 1/2, or √3/2. And this length here is also the y value. Well, sort of. Technically, negative √3/2 is the y value because the length is √3/2, but the direction is down. So this is saying go down, and this is saying the length, right? Okay, so what is this thing? It's minus square root of 3/2. It's sort of how you enter it in web work. And since it says, not a decimal, so square root of 3 is something like 1.7 stuff. And so if you divide that by 2, you'll get 0.85 stuff. And you don't want to enter that, right? You want to enter this. It shall be negative, but whatever. Okay, so 30, 60, 90 triangle, very useful. And the ratios are sort of the short leg is half the hypotenuse, and then the other leg is square root of 3 times the short leg. So, all right, and as far as 45, 45, 90 goes, this is a nice one, very easy, very simple. Because 45, 45, these two angles are the same, which kind of means these two lengths are the same. And then this has to be √2 times x. So if you have something that maybe it asks for like 5 pi over 4, then you should think of that as pi plus an extra pi over 4. In fact, let's just pretend for a moment that this was 5 pi over 4. Okay, so I want sine of 5 pi over 4. I want sine of 5 pi over 4. So I would draw a circle. Draw a circle, attempt number 2. Great. And I think to myself, well, gosh, pi, that's 180. And then I go an extra pi over 4, which is, so pi over 4. It's exactly half the distance, like it's half of 90, right? It's half of a pi over 2. 1/2 of a pi over 2 is a pi over 4. Okay, and so now we kind of draw this triangle, and this is x, and this is x, and this is √2 times x. And we'd say, well, wait a second, this is a unit circle. It's a unit circle, which means the hypotenuse is equal to 1. And we'd say, okay, so x is 1 over √2. And so that means the sign, we're going down. So the y value, okay, x is sort of a bad name because I have a coordinate named x and I have an unknown named x. So sorry, the x coordinate is negative 1 over √2 because I'm going to the left. The y coordinate is negative 1 over √2. And maybe I should have called this like L for leg, right? Anyway. All right, so that's what's going on there. I'd rather we handle trig when we get to trig versus trying to teach something and then not talking about it and then just assuming you remember it when we need it again in the future. I'd rather just teach it when we need it. Okay, so let's tackle this thing. Some vocab. All right, amplitude. Amplitude. Well, let's come back to that for a moment. Let's talk maximum value and minimum values. I'm going to call this little m, and I'm going to call this big M. Okay, so the amplitude is, how should I say this? It's big M minus little m over 2. All right, so if I cut this in half, boom, I'll call that A for amplitude, then sort of this distance here from the midline up to the peak, that's the amplitude. Okay, so if we stare at this, I'd say, well, let's see. My minimum value looks like it's at y equals -1. So -1. And my maximum value got 1, 2, 3. Okay. So my amplitude, I do 3 minus -1 over 2. I get 2. This full distance is 4. It's just half that full distance. That's all we're doing. So if you don't remember this formula, that's totally fine. There's many other formulas for it. At the end of the day, you're just trying to get half this distance, okay? Half the distance from the minimum to the maximum. So this is 2. Okay, period. Hey, have you ever heard the term a period in history? Okay, a period is a length of time. Not length of time. All right, so what type of length of time? Well, it's the length of time for this thing to repeat. So what do I mean? So if you pick a spot, that's really easy to recognize again. So I'm going to pick the peak. Then I go to the next peak. Okay, this length of time is called the period. So I'd ask myself, how far is it from here to here? And it looks like it's 1. But there's nothing special about the peak. I could do the valley. And now it's really easy to see this distance, the period, it's 1. Okay, the period is 1. You could also do a midpoint, but then you have to be a little bit careful. Because notice here's another midpoint and here's another midpoint. And these have distance 1/2. So when I say a point repeats, a midpoint, I'm sort of at the midpoint traveling uphill. Here I'm at the midpoint traveling downhill, so that's not actually a repeat. That's a different type of thing going on. Here's the repeat. That's midpoint going uphill. So anyway, I would recommend not using midpoints for periods. I would use either peaks or valleys. And so you can just go from valley to valley or from peak to peak. And then it's just that measurement in time. Or just the x distance, okay? So that's all that a period is. All right, now let's put this all into a formula version. So let me, I see, kill that. Let's get this going. Big, big, big. Great. Voila. All right. So now we need to find a formula for the trigonometric function. All right. Here's the idea. We're going to have an amplitude times, and then there's sort of 2 versions that we can look at. So amplitude, it's either a cosine or a sine. Okay. It turns out this one's going to be a sine. We'll talk about how we know that. And then you could think of it as 2 pi over the period. All right. And we typically use capital T for period. Again, a mnemonic is a length of time. So capital T is telling you some length of time. This is the period. And then we have x minus, and I'll call it phi. And this is called the phase. And this is the amplitude, right? So we sort of need 3 pieces of information. We need a period, we need an amplitude, and we need a phase. Okay. So now, how do I know it's sine versus cosine? So sine begins at a midpoint, and then it'll either go up or down. Whereas cosine, so, whatever. Oh, hey. Cosine, if I was looking at cosine, cosine begins at a peak or a valley. Okay. So, both these problems, we're going to do a sine. We might just make it where you only ever have to use sine in the class. I don't remember that being said in the meeting, so regardless, it's still going to be this type of idea, x minus phi, okay, and it's still a period and an amplitude and all that stuff. So, all right, let's find the period, and, it sort of sucks having to use midpoints. I just said don't use midpoints. We could go from the valley to the valley, and you'd sort of just have to guess, what this is, which sort of sucks. Okay, fine. So we have this midpoint talk. And remember last time I said midpoints, when you hit it again, you have to ask yourself, are we going uphill or downhill? This is going down, so we skip it. Here's a midpoint, and now we're going up. So the period is actually this whole distance here. And now we can read off that that's 6. Okay, so t is equal to 6. Okay, now the phase, if I'm using sine, then I find the middle going uphill, and I ask myself, is that middle going uphill, is it on the y-axis? In other words, does it occur at x equals 0? And yes, it does. So you could just think of phi as being the location of where that happens, and this is at 0, so it's going to be the x location of sort of the mid uphill. Okay. I'm lying a bit, but we will handle something a little different in the next problem. So, okay, that's fine. And what else do we need? Amplitude. We need amplitude. Well, hey, look, the max is at 5 and the min is at 3. So we need half that distance, the distance from 5 to 3, big M minus little m, and you divide it by 2. That's going to be 2 over 2. That's 1. Okay, so the formula, putting everything together, is 1, don't even bother writing it, times sine of, and now I'm going to have 2 pi over 6, that's this thing, but this will cancel, you get pi over 3, so let's put pi over 3, and then phi is 0, so it's just, oh, sorry, I need an x, I could write x minus 0, but again, why do it, right? Just x, boom. Here's the formula for this. Sorry, I forgot one more thing, sorry. We could shift it up, plus, I don't know what the book calls it, I'm too lazy to look it up. This is sort of the average, so we'll call it little a, AVG, I don't know. It sucks because we got amplitude and we got average, so I don't know what the book calls it. Okay, so if if it was just this, sorry, my brain sort of was on one track, and well, sine of 0 is 0. So this graph here would go through that point. It would kind of look like this. Whatever, I don't know. Okay, well, I do know. It's just that it's hard to draw because I don't have whatever. So we need to shift it up. Okay, we need to shift it up 4 units. Okay, so the average, very similar computation to the amplitude, but now we're going to do a plus. I would just read it off from the graph. You can just find where that midpoint is on the y-axis. And so our actual final answer, sorry about this, it's this plus 4. Okay, great. So that'll shift us up 4 units, and then we'll be here. We're going to travel along where we need to travel. Sorry, here's the average. Okay, so gross, I will happily help you with any of those, but if we hit it hard now and then don't touch it again, if you're like me, you would just try and memorize it in the short term and then forget it. So let's cross that bridge when we start interacting with sines and cosines more. Okay, so. Very similar problem. Let's take a peek. Whoop. Great. Let's just put down the idea. Amplitude, sine 2 pi over the period, x minus the phase, plus some kind of average shifty movement thing. All right, so first off, I can see my average happens at y equals 10, so I'm just going to knock that out real quick. Okay, we got this. Boom, plus 10. That's handled. Let's move on to look at the other stuff. All right, let's find the period. So here's a midpoint going down, midpoint going up, I don't care. Midpoint going down, great. So this distance is the period. And what is that? Oh, disgusting. They gave me terrible numbers. Did they give me terrible numbers? No, they didn't. So 2 bars, 2 dashed bits is 11. And I have 1 dash bit, but another dash bit. So it looks like my total period is 22. Here, I'll make it easier on us. Let's do this. Let's look at the valleys. Okay. And now you can see I have 11 plus another 11. Okay, so my period's 22. All right, so let's go ahead and start to fill that in. 2 pi divided by 22, the 2's would cancel, you would get pi over 11. Okay. All right, now this is where, this is a good example to actually use cosine instead of sine, but I'll use sine first. Okay, so it's use sine. We find where there's a midpoint going up, okay? And we ask ourselves, where does that happen? What kind of like x value? Okay, and this is phi. This is the phase angle that we're looking for. And it's 1/2 of 11. Fine. Oops, sorry. I'm so used to crossing to make a pi. It's 1/2 of 11. Fine. Whatever. Just let it be. It's fine. It's fine. It's fine. Everything's fine. Okay. 1 pi again, you know? It just wants to show up. 1/2 of 11. Great. And now we need an amplitude. So that's just this distance here, which is the same as this distance here, which we can read off as 10. 10. Okay, so there's an answer. Let me just show you if you're curious about how to do cosine. So same idea, a cosine. And now this number's the same, and this number's the same, and this number's the same. So let me just fill all that in. We'll make this pi over 11. And then we have x minus, this number's not the same. I gotta calm down, man. All right, x minus phi, boop, close it, plus 10. All right, so if you're dealing with cosine, and you've got this phi, you wanna find the peak. Okay, so here's the peak. And I asked myself, where does it happen? It happens at 11. So I could just plug in an 11 right here, 11, and there's my answer. Okay. So the only difference between sine and cosine is what goes right there. And for sine, you sort of want that middle spot going uphill. And for cosine, you want a peak. Okay. So, all right, that is it for the trig stuff. I am going to do one dynamical systems problem. And then I'll make a video about dynamical systems as well tonight and post that. That's what our handout is on. Okay, so, all right, a population of bacteria quadruples every hour, but 7 million bacteria are removed before reproduction. Okay, so we want to come up with an updating function. Let's just make a little table real quick. All right, so we got T, and then there's the bacteria time T, and then there's the bacteria time T plus 1. All right, so blah, blah, blah. They do not give us an initial value of bacteria. So let's just pretend at time 0, we had 10 million, okay? So now, 1 hour later, what has to happen? So 7 million are removed before reproduction. So that 10 becomes a 3. Okay, and then what? Then we quadruple. So then that 3 becomes a 12. So 1 hour later, we have 12 bacteria. Put this here. Okay. All right, so now 12, we have to remove 7 million bacteria, and then we have to quadruple. Okay, so what is that? I don't know, that's 4 times 5, that's 20. And actually, notice what I just did here. This is the whole idea. So 12, that was the bacteria. In this case, that was time 1. But actually, how did we get the 12? How did we get this number here? We did 10 minus 7, and we multiplied that by 4. And what was 10? That was B0. We took away 7 because we removed 7 million before reproduction. And then they just reproduce like mad, so we get 4 times that amount. And that was going to be B1. And then for B1 minus 7, that's going to be B2. So with numbers, we all can often actually start to figure out what it is, but then we have to eventually let ourselves just sort of not use numbers, right? I made up this number 10. This is actually just B0. And then what do you do to compute B1? Well, you take B0 and you subtract 7, and you multiply it by 4. And there's nothing special about B0. So, at time t, you have BT, okay? How would you get BT plus 1? Well, you take BT, you subtract 7, you multiply it by 4. Boom, there it is. Okay, so distribute that 4. We have BT plus 1 is 4BT minus 28. So that's what my problem would be. Now, if instead of being removed before reproduction, if it was removed after reproduction, then however much bacteria is there, it gets to reproduce. So quadruples. But then I remove 7. So this number here would not be -20, it would be -7, but that's if it was removed after, right? So hopefully that makes sense. The order matters, okay? All right, I'll see you next time. I'll post a video about the worksheet I handed out.